PYQ'S.com.
Okay, okay, students. Now we are going to start previous year questions. These questions are picked up from the three examinations: NEET exam, IIT, and advanced. So that from the basic level, you should be able to reach to the utmost top level. And I will try to explain the each and every question with detailed explanation so that all related questions you should be able to solve. And already on the stoichiometry, we have one shot lecture also. You can go through that if not gone through it. Okay. And while going through the stoichiometry one shot lecture, you can select one of the difficult topic, and that topic you can go through the detailed lecture. Each and every topic is detailedly explained, one shot explained, and we will go through the previous year question. After that, you will get one DPP also, so that your preparation level is up to mark or not, you can check. Okay, three levels. First, go through the one shot, identify the difficult topic, select that topic and go through the topic, then attend the previous year question, then you will go for the DPP. So when you go through these all four levels, nobody can stop you to get a good seat in the for medical. Definitely from chemistry side, from this chapter, I can assure that you will be names. If you are appearing for the IIT, definitely this vastly covered, so that you should not have any problem in getting seat in IITs. Okay. So let's start with the first question. Okay, here we got the two questions, and these first question is from the NEET. So like that combination is there, some mains question with the year it will be mentioned. This is the AIMS question 2012. Okay, so you can try yourself, and then I will explain with complete detail, and if any shortcuts are there, that also I will explain. Okay, here first answer I am explaining, and I will try to explain on the whiteboard if required. Okay, so here the question is about the vapor density of mixture containing NO2 and N2O4. Okay, so from NO2 and N2O4, we have to find out what is the vapor density. Okay, so first of all, I will explain. See, vapor density maximum will be equal to mole fraction of NO2. Okay, mole fraction of NO2 is only we want. Okay, mole fraction of NO2 into vapor density of NO2. Into vapor density of NO2. Okay. Second, what we have other thing N2O4. So mole fraction of N2O4 into vapor density of N2O4. Okay. So or we can say mixture, vapor density of mixture. Okay. But then I will write, it will be clear to you. So vapor density of the mixture is equal to simple mole fractions. Okay. And all of you are aware that the sum of the mole fraction will be 1. So vapor density of mixture is given as 27.6. And my intention is to find out the mole fraction of NO2. So I am taking it as X. Okay. X into vapor density of NO2. Vapor density of NO2 means molecular mass of NO2 divided by 2. Okay. So molecular mass of NO2 will be how much? 14 plus 32. Okay, that will be 46. 46 by 2, that is 23. Okay, X into 23 plus here this will be 1 minus X into its vapor density will be N2O4, so it will be 46. Okay, on simplifying, you will get the XNO2, mole fraction of NO2, that you will get around 0.8. So A option is correct. First question, I think it is clear to all of you. Formula we have used is vapor density of mixture is equal to mole fraction into its vapor density. Okay. Then next question, C, aqueous solution of 6.3 grams of oxalic acid. Okay. Oxalic acid, if you don't know the formula, COOH whole twice, the simplest way to write. But here it is dihydrate. That means dot 2H2O also you should take. So if you don't consider, then it will be a problem. Okay. Then neutralization. For complete neutralization, what we require to have milli equivalents of both must be same. What must be same? Milli equivalent of both must be same. Okay, so here this I will explain in the whiteboard. Just wait a minute. Okay, so here I think whiteboard is visible to all of you now. Okay, here simply in any neutralization, in any redox reaction, once we say reaction is complete, then both milli equivalent must be same. Okay, here in case of this question, oxalic acid is A and NaOH is B. Okay, so milli equivalent formula will be normality into volume. Okay, if it is in milliliter, then it will be milli equivalent. If it is in volume is in liter, then it is going to be equivalent. It is going to be what? Equivalent. Okay. So therefore, first of all, our essential condition is that normality we have to find out. Okay. So 6.3 is the mass. Equivalent mass is 63. 126 is the molecular mass. So, but I have taken it as a equivalent mass. 63 volume is in milliliter into 1000. Okay. Then you will get the 0.4 normality. Now let us take this as an acid and this as a base. So here 0.4 normality 10 ml and base 0.1 normality volume we have to find out, it is 40 ml. Okay, I think it is clear to all of you now. So let's see the next one. Okay, so here answer to according to our question, answer is 40 ml. Okay, this answer is 40 ml and this answer is 0.8. Okay, now let us see the next question. Let's go for the next questions. Okay, so don't get worried if it is difficult, then I will try to explain it all so that you should not have any problem. Okay. Now KMNO4 react with oxalic acid according to this reaction. Okay. 20 ml of 0.1 molarity given it is. Okay. You have to convert into normality for equivalents. But with the previous explanation, I think you will be able to do that. Okay. So equivalents of KMNO4 and equivalents of H2C2O4 must match. Okay. So first of all, you should know the equivalent factor of KMNO4. Okay. And it is already given H plus. That means acidic medium you have to take. And oxalic acid change in oxidation number. It will be from +3 to +4. Okay. And 2 are there. So equivalent factor will be 2 for here. And for this, it will be equivalent factor will be 5. Okay. So let's hope all of you will solve and then cross check with me answer. Okay, here's what is the formula for converting molarity into normality. Whatever the molarity is there, you multiply it with equivalent factor. Okay. So here molarity is given as 0.1 and equivalent factor for KMNO4 is 5. So normality of the KMNO4. Normality of the KMNO4 is how much? 0.5 normality. Okay. And 0.5 normality into volume is how much? 20. So 20, and that means you will get milli equivalent of 0.5 into 20. Then 10 I will get. Okay. 10 milli equivalent. So you have to cross check. Here molarity is given. So molarity for oxalic acid you should multiply with 2. Okay. So with 2. Okay. Molarity with 2. So see here 0.1 into 2, 0.2 into 50. 0.2 into 50, 10 milli equivalent. So C is the answer. Now after noting down, you can try for the next one. Calculate normality of 10 volume H2O2. So this is the procedure. Actually H2O2, here volume is given of H2O2. That means 10 liter. 10 liter of H2O2 is produced from 1 liter of solution. Okay. So here it will be 68 from where we got it. Its molecular mass is 34. Okay. Equivalent factor is 2. So like that we got 68 into 10 divided by 22.4 liter. Okay. So here I will tell you 2H2O2 gives 2H2O plus O2. Okay. So here this mass is 68. From this I got the 68. So 2 into 34 grams, that is 68 grams gives how much? And that is equal to 17 into normality. Why 17? Equivalent factor of the H2O2 is, and when you divide you will get the 17. Okay. So answer to this question is A option. Note down and let's see the next question. Okay, next question is which of the following have maximum number of molecules? Maximum number of molecule. Okay. So direct trick I will tell you. What is the direct trick? You will find out the moles. Okay. So question is about the molecules. Sometimes they may ask. Sometimes they may ask into the number of atoms. That time you have to multiply with multiplicity. Okay. Okay, you don't get confused with the mass. See, 44 its molecular mass, so here it is 1 mole, and 48 is its molecular mass, therefore it is 1 mole. SO2 is molecular mass 1 mole, but here it is 4 moles. Okay, so answer will be C answer. Now let us see the next answer. Sulfur forms chlorides S2Cl2 and SCl2. Equivalent mass of sulfur in SCl2 is, okay, equivalent mass of sulfur in SCl2. Simple, here chlorine and chlorine. This will be more electronegative, therefore it will be -1 and -1. This will be +2. So equivalent mass of sulfur in SCl2. So you should take only the sulfur mass, okay. Sulfur mass is 32 divided by 2, then you will get answer as 16 gram per mole. Okay. What is the answer? 16 gram per mole. Note down this. Then we will go for the next question. Okay. Next question. Arrange the following in the increasing order of mass. Okay. Question is arrange the following in increasing order of mass. And here mass, 1 atom of oxygen, 1 atom of nitrogen, mole of oxygen, mole of copper. Okay. So very simple. 1 atom of oxygen is not 16 grams. 16 by Na. Okay. And here it will be 14 by Na. Okay. And here it will be 1 mole of oxygen means 16 into 10 to the power of -10. Okay. And here it will be 63.5 into 10 to the power of -10, because this is a mass of 1 mole of. Okay. So accordingly, when you arrange the correct order, answer 1 will be correct, I hope. Okay. Second will be less than, first less than, third less than, fourth. So answer to this question is what? A answer. Okay. Now you try the next one. Volume of water needed to mix with 10 ml of 10 normality HNO3 to get 0.1 normality HNO3. Okay, here simple. People do the half process and start answering. Okay, this is the fascinating answer. Most of the people feel that A option is very easy. Okay, so N1 V1 is equal to N2 V2, that I will expect. But here question is not volume of final solution. Okay, so here volume of final solution will be correct, but other part is wrong. Okay, normality is how much? N1. Okay, 10 normality. That time 10 ml, and we wanted to get 0.1. Then V2 is equal to, V2 will be 1000, but not 1000. 1000 is final volume. Already 10 ml is there. So how much we need to add? 990 ml of water we need to add. Okay. That's why I explained in the one short lecture. That is what the problem. People don't want to spend time more on the studies. Okay. V2 minus V1 is the water volume. Okay. So answer will be B option. Okay. People are ready to spend so much of time in internet for all unnecessary things, but when they come to study, for every 5 minutes they will count the GB, MB like that. Okay. Okay, here I am explaining. This is advanced question. First of all, mole fraction. We have to find out what mole fraction. Okay, decreases from 650. We have to find out first mole fraction. 650. Okay, decreases from 650. Understood? Depression freezing point. Non-ionic to 30 grams of vapor pressure decreases from 650 mm of Hg. Okay. Actually, it should be written, there is a print mistake, Hg to 640. Okay. 640 mm of Hg. Okay. So then it will be okay now. So here, depression in relative lowering of vapor pressure. Okay. 650 minus 640 divided by 640. This is the mole fraction of solute. What is this? This is mole fraction of solute. Okay. Now with this you will find out the depression in freezing point. In the depression freezing point is uh, okay, depression freezing point will be delta TF is equal to non-ionic it is given. Therefore, it will not dissociate into ion. Therefore, its mole I value will be 1. Okay, 39 grams of benzene. Okay, delta TF is equal to I into KF into molality. Molality is what? 0.5 divided by molecular mass. Okay, then divided by mass of solvent 39 into 100 into 1000. So by using this small fraction you can find out the molality, then you will get the depressional freezing point delta TF. Okay, so that is what that question. Now let us see the next question. 1 mole of rhombic sulfur, okay, treated with concentrated HNO3, find the mass of H2O formed. So this equation, if you are not able to find, then I will try to give you the equation. Okay. Okay, here it is the equation. S8 plus 48 HNO3. So here 1 mole. Main problem is that rhombic sulfur. Rhombic sulfur, this you have to take as a S8. Okay. So you have to balance with 1 mole of S8. S8 plus 48 HNO3 gives H2SO4, NO2 and H2O. So that means 1 mole is giving 8 moles, sorry, 16 mole of H2O. 16 into 18. Only if you are balancing right and taking S8, then no problem. Okay, 16 into 18 if you are doing, then you will get 288. Answer is how much? 288. Okay, next question. Measure the quantity of MnCl2. Quantity of MnCl2 dissolved in an aqueous solution. It was completely converted to MnCl2 is completely converted into KMnO4. Completely converted into what? KMnO4. And few drops of concentrated HCl were added to solution warmed, where further oxalic acid added, so that till the color of permanganate is. That means KMnO4 is again disappeared. The quantity of MnCl2 present in initial solution is. Okay. Okay, here MnCl2 is converted to KMnO4. And how much KMnO4 formed, that is identified with the help of the oxalic acid. Okay, already it is given 225 mg is added. Oxalic acid mass is 90. Okay, there it was dihydrate dot 2H2 it was there. That's why 220 126 we have taken. In this question, oxalic acid is plain, that is 90. Okay, and its equivalent factor will be 2. So this is moles, and into 2, then you will get the milli equivalents. And how you will find out KMnO4? Simple, KMnO4 equivalent factor will be 5. Okay, equivalent factor will be 5. and millimoles of MnCl2. Here moles of quantity of MnCl2 present in initial solution. So from this, if you find out X, so X will be millimoles of KMnO4. KMnO4 will be equal to MnCl2. This is what principle of atom conservation. Okay, number of atoms will never go increase or decrease, because see 1 Mn is here, so number of moles of KMnO4 produced will be equal to number of moles of MnCl2 available. So here X moles let us take, so that X we got it here. Okay. So answer will be X if you find out 1 mg. Okay. So 1 milligram. Understood? So 1 millimole. Okay. 1 millimole. So 1 millimole means 55. Magnesium I think given here 55 plus 71. So 1 millimole means 126 milligram. Millimoles will be in milligrams. Okay. Answer is 126 mg. Next is galena is a partially oxidized by passing through a high temperature. After some time passage is stopped, but heating is continued. That means first calcination, then it is roasting, so that all content undergoes self-reduction. The weight of kg, weight in kg of lead reduced. Galena is a lead PBS, okay, produced per kg of O2 consumed is. Okay, here galena is PBS. First it is oxidized. When it is oxidized, it will convert into PbO. This is a self-reduction process, okay. Now this lead oxide and leftover PBS both will undergo auto reduction to give the lead. Basically what we mean to say is 3 moles of oxygen we have used and 3 moles of lead is produced. Okay. So 3 moles of oxygen is equal to 3 moles of lead. Then 1 mole of oxygen is equal to how much? So answer will be 6.47 kg. 6.47 kg. Okay, I think it is clear now. Okay, next question is freezing point of 4% aqueous solution of X is equal to freezing point of 12% aqueous solution of Y. Then molecular mass of weight of X is equal to A. Then molecular mass of Y will be. Okay. Okay, here molality we will find out. Okay, here molality we will find out. 4% aqueous solution means 4 grams of solute. Okay, molality I am writing it here. 4 molality divided by molecular mass. Divided by mass of solvent we will take 96. Okay, and it is in grams, therefore into 1000 molality. Same way here also it should be same molality. So 12%, so 12 grams of solute, molecular mass Y, solvent will be 88 into 1000. Anyhow, this and this will get cancelled. So molar mass of Y will be 12, okay, by 88. Then this will be cross multiplied. 88 into 4, here it will be 96. You will get something in 3 point. You will get something in 3.27, but nearby option is there 3. Okay, note down this and let's do the next question. Now here 2 questions are there, so do one by one. Don't be in hurry. Solve it one by one and cross check with my explanation. 2 questions are there, so do it one by one. Cross check with my explanation after solving. Okay, see, note down. Okay, here whatever the values given here, I have noted down and I am explaining. So before that you should be able to note down. Okay. Now let's see the whiteboard so that you can understand it clearly. Okay. See here, CaOH whole twice when treated with Na2SO4. It will give you the CaSO4 and NaOH. With the given mass, I found the millimoles as 100 millimoles and 14 millimoles. So here both are 1 mole only required. That means here limiting reagent will be Na2SO4. Limiting reagent will be Na2SO4. Okay. So according to that, the product will be there. If this is 1 mole, this is also 1 mole. If this is 1 mole, this will be 2 mole. So this was 14 millimoles. So this is the same to same it is written. So 14 into 2, 28 millimoles. Okay. So answer, we require mass of the CaSO4. 14 millimoles are there. Okay. So 14 millimoles means 14 into 10 to the power of minus 3 moles into molecular mass 136. So I will get as a 1.9 gram. And another thing they want, concentration of OH minus. Simple, 28 millimoles. Okay. So this will be 28 upon 100, that is 0.28 molarity. What is the answer? Point here 100 million, 0.28 molarity. Here we have written the equation. First we identified the which is limiting reagent. According to limiting reagent only we will get. Understood? So it is 100 millimoles. How it is 100? See, let us see the in the question. Okay. In the question it is given 100 millimoles of, okay, 100 millimoles and 2 grams of sodium sulfate. The 2 grams I have converted into moles. Okay, so 2 gram divided by 40 grams, sodium sulfate. Okay, then you will get the millimoles of the sodium. Okay, so how I got these values, I think it is clear to all of you now. And 100 milliliter. So 14 millimole I got it by dividing the 2 gram. By dividing the 2 gram with molecular mass. Okay, then I got 14 millimoles. And this is already given 100 millimoles. So this is limiting. Product will be as per the limiting. So molarity of the NaOH will be 2 millimoles. Divided by volume is given as 100 milliliter. So millimoles per milliliter will get the molarity 0.28. So this answer is 0.28. Okay. So let's see the which option is correct. Okay, which option is correct now? C option is correct. Okay, 0.19 grams and 0.28 millimoles. I think it is clear to all of you. Okay, in this question, 8 grams of NaOH. 8 grams of NaOH in 18 grams of H2O. So simple, 18 grams means 1 mole. Okay, because I am talking about this mole fraction. Okay, and for molality it is not required. Simply mole fraction I am writing it here. 8 by 40 divided by 8540 plus 18 by 18. So answer you will get, I hope, 0.167. Molality will be 8 by 40 divided by 18 into 1000. Okay. Then you will get 11.11. So A option is correct. Okay. Then strength of 11.2. Strength of 11.2 volume of solution of H2O2 is given as strength you have to find out. Okay. So there is a direct formula. I am writing it here. Volume strength. Volume strength is equal to 11.2 into molarity. 11.2 into molarity. Okay. So here that means molarity is equal to how much? 1. 1 molarity means 1 mole in 1 liter. 1 molarity means 1 mole in 1 liter. 1 mole what? Here H2O2. Okay. So 34 grams, 34 grams of H2O2 is there in 1 liter 1000. Okay. So on simplify into 100, percentage is there. So into 100, then you will get 3.4%. What is the answer? 3.4%. I think it is clear now. Very easy question, but you should not get confused. Okay, next, most abundant element by mass. See, there are so many problems are there. Most abundant, sometimes they will ask by volume, by mass. in the earth crust or in atmosphere. Okay, but in the body of a healthy human are oxygen is 61.4, carbon 22.9, hydrogen 10%, and nitrogen 2.6%. Okay, weight which a 75 kg person would gain if all atoms are replaced by 1h2. Normally in our body we will have 1h1. Question is that if we replace all 1h1 with 1h2, what will be the now gained weight? Suppose your answer is new weight is 80, then new gained weight will be 5. Like that you have to find out. Replace all with the 1h2, then find out the total mass, then you will find out the difference. Okay, that is a good question. This is recently 2017 question in mains. Okay, very simple. We are replacing the 10% extra. Okay, 1h1 is replaced by 1h2. So there will be increment in the size, incremental in the mass by 7.5 kg. Okay, we are increasing the 10% again. So the 10% will be 10% of what? His body weight. 7.5 kg is the answer. Okay, now let's see the next one. Ratio of mass percentage of carbon hydrogen. Only 6 and 1 is given. Okay, contains half as much as of oxygen burnt one molecule completely to CO2 and H2O. The empirical formula of the compound is. Try to solve this carefully. When this question came, I remember 3 students could not understand what is the question. So they have to read, you have to read the question twice, then it is easy. Understanding is difficult, but once understood, it is easy. Okay, so this is somewhat lengthy question, so I will try to explain it on the whiteboard. Okay, now let's see the whiteboard. Here, first of all, what are the given that I am going to write? We are given with carbon, hydrogen. Okay, relative mass or atomic mass, relative masses is given as 6 and 1. Okay, already you know when you divide mass by atomic mass, by atomic mass. So this will be 0.5 mole, this will be 1 mole. Okay. So when you divide it both by 1 and then it will be 1, 2. Okay. So therefore empirical formula of the hydrocarbon CXHY. Okay. So CXHY on combustion. This C will require 2 oxygens. Okay. X plus Y by 4 O2 will give you CO2, X moles of CO2. X moles of CO2 will be generated and Y by 2 moles of H2O will be generated. Y by 2 moles of H2O will be generated. Okay. So from this we can understand molecules. So for atoms 2 into X plus Y by 4 atoms are required. What required? These many atoms required. Okay. So as per formula, and it is equal to what? Half, double the number 2z. Okay. So 2 into x plus y by 4. 2 into x plus y by 4 is equal to 2z. 2 and 2 will get cancelled, and x plus y 1. Here already we come to know that x is equal to 1. So 1 plus y is equal to 2. 2 by 4 is equal to z. So that means z is equal to 1.5. Z is equal to how much? 1.5. Okay. So once it is 1.5, we can write it as a CXHYOZ. So X is we are taken as a 1. Okay. Now H we have taken as here. Hydrogen we have taken as a 2. And oxygen we got it as a 1.5. But it cannot be in fraction. Therefore C2 H4O3 is our answer. Okay. Note down very carefully, very important question. Just they are not able to understand what we have to do with CO2 and H2O. Okay. Now let's go to the slide. Okay, this was the question. So our answer, whatever answer we got it, that matches with the A option. That matches with which option? A option. Okay. Okay, here it is a detailed solution. When you balance it, you have to balance with 2HCl. And moles of CO2 produced is only 1 mole. So M2CO3 produces CO2 and it is given as 1 gram. Given as what? How many grams? 1 gram. So 1 gram gives 0.00.01186. Then 1 mole, that means molecular mass gives how much? Okay. Molecular mass upon 1 into this. So molecular mass will be 1 upon 0.01186, then you will get 84.3. Okay, I think it is clear now. Now let's see the next question. Okay, next question is displayed. Start answering. Okay, molarity of solution obtained by. There is a tricky question, so don't get misconception. Okay, here molarity of HCl obtained by mixing 750 ml of. So simply what we will do, M1 V1 plus M2 V2 divided by V1 plus V2. Okay, so here this will be V2 and 250, 750 will be V1. 750 will be what? V1. Okay. So 750 V1, 250 V2. M1 will be 0.5, M2 will be 2. On simplifying, you will get 0.875. Okay. Here the ratio of masses of oxygen, molecules. Actually, molecules moles will be same as mole ratio. Okay. So 1 divided by oxygen molecular mass will be 32. Same way, nitrogen 4 divided by 28. Okay. On simplifying, I am getting 7 ratio 32. I think you will also get same answer. Okay. So let's go for the next questions. Okay, next question is little bit easy, appearing to be easy. Okay, then 54 mass number is of 5%, 56 mass number of 90%, 5% mass number 57. Okay, then you have to find out the atomic weight. Very simple, but calculation part it should be. Okay. Okay, here we have to use 5 into 54, 90 into 56 plus 5 into 57 divided by 100. So simple if you do, then you will get 55.95. Okay. Then dissolving 120 grams is so fancy number, 120 by 62 moles. Okay, how many moles? 2 moles in 1000 grams of water gave a density of 1.5. Okay, so direct formula. Okay, which chem trick? Which chem trick? Okay, molarity is equal to mass percentage into density into 10 divided by, here it is mass percentage by molecular mass. Okay, so mass percentage you will write it, you will find out. Okay, and 1.25, 120 grams, otherwise we can do it directly also. Okay, 120 gram, 2 mole divided by volume, mass into volume, this will be 1.15 liter only, direct. Okay, so you will get 0.97. So 2.04. Okay, density, sorry, here it will be 100, 1000 divided by 1.15. Then you will get answer of 2.05. What is the answer you are going to get? 2.05 molarity. 2.05 molarity. Okay. Noted. Now let's go to the next question. What has the maximum number of atoms? Okay, in this we have to just compare. When you have to just compare, what you will do, you will find out the moles. That's it. Okay, 2 grams of carbon. That means, sorry, 24 grams of carbon. What does it mean? There are 2 moles. Okay, here 2 mole of atoms. Here 1 mole of iron. Okay, here 1 mole of aluminium. Here 1 mole. So maximum moles are there. So maximum atoms will be there. Okay. Then see, this is very good reaction. This will be useful in your qualitative analysis. Okay. This will be useful where in complex. Okay. Qualitative analysis. Mixture of zero point 0.02 mole of this and 0.02 mole of this was prepared in 2 liter. Okay, actually Ag can react with bromine. Okay, Ba can react with this SO4 to form BaSO4. Okay, so now the number of moles of X, Y and Z are. Okay, here, so if in this reaction, if AgNO3 is reacting, only it will replace the bromine. Here you can find NO3 is replaced. Okay, here bromine was there, that's the place NO3. Same way here SO4 will be replaced with Cl2. Okay, so there won't be any change but 2 changes. Okay, so there won't be how many? 2 changes. Okay. So then answer you will get after simplification, answer you will get A option. Okay. Both will be 0 0.1, 0 0.1. Actually it is 0.02. But here 2 moles are required per mole. Okay. 2 moles are required per mole. Therefore 1:1 only answer. Okay. Here sodium ferrocyanide means Na4FeCN6. Na4. Okay. Na4FeCN6. Na4FeCN6 is the answer. Okay. So accordingly, you can calculate number of sodium in 2 moles. Simply 4 multiplied with 4, then you will get D option. Okay. You will get D option. Okay. Next, how many moles of electron in 1 kilogram? So 1.6, sorry, 1.9 into 10 to the power of, sorry, 9.1 into 10 to the power of minus 31 is equal to 1 electron. Then 1 kg you have to find out. Okay. So then also again here also you will get D option. Okay. Okay, next questions are here. Total number of atoms represented by the compound. Okay, represented by the compound. So copper, sulfur, oxygen, like that you have to calculate all of them. Okay, total number of atoms. Total number of atoms, if you count simply, you will get how many? 1 plus 1 plus 4 plus 5 2 is 10 plus 5. Okay. So 15, 20, 21. Okay. Next, equivalent weight of phosphoric acid in H3PO4. Okay. Simple, in H3PO4 only one hydrogen is replaced. So one hydrogen replaced, therefore H3PO4 molecular mass divided by 1. Okay. Answer will be 98. What is the answer? Answer will be 98. Okay. Note down this. Okay. Thank you for watching VIJ CHEM. I wish you success in your all exams which you face. Okay. So don't forget to go through the one shot if you got any doubt, any topic, or you can choose the individual topic also and wait for DPP on this topic. Okay. See you. Bye bye.